Good morning, everybody. We're going to get started here. So I'm going to do quickly attendance. All right, so 7439. All right, now let's take a look at where we are and where we're going. All right, always important to reflect. So I'm going to go ahead and do that. So we're right now on March 30th. So we're covering 3.7 today. We'll cover 3.10 this Thursday. Now be mindful that next week will be our test. So it'll be next Thursday though. Okay, so next Tuesday we'll do the review for the test 3. All right, so we cover that. All right, now let's take a look at the lesson then. Let me see here. All right, so we're going to be focusing in on the concepts of the graph again. All right, so we've been looking at graphs before with respects to like slopes and stuff like that. So now we're looking at just different aspects of the properties involving linear functions. When they ask for the x-intercept, they're asking for where does the blue line basically cross over the x-axis. That's what they mean by x-intercept. So it's a very simple structure. All we're doing is seeing that this is passing over this gray line here at the value of -4, someplace, on that line. So you got to just give it an indicated number. So now, likewise, with the blue line crossing over the y-axis, we're going to cross over at 1. Now, it's more appropriate that actually that these would be indicated at -4 is 0 and 0 negative, or excuse me, 0 1. I mean, so we can identify the x and the y-intercept at x and y values, but they're not asking us to do that. So all we have to do is basically give the number. So it keeps it easy. So in this case, then the x-intercept is at 1, and the y-intercept is at -2. So now it says write an equation in slope-intercept form of a line with slopes 2/5 and y-intercept -9. Now, all slope-intercept form is this formula, y equals mx plus b. Now, the y and the x represent the output versus input, and the m is the slope, and the b is the y-intercept. So when they give us values such as the slope and the y-intercept, all we have to do is insert them in these positions and just call it a day. We're not solving for anything. All right, so we're looking at then y equals, because it always starts with y equals, because that's input versus output. And we've talked about a little bit about input and output before. So then the slope is 2/5, so that's the value of m. And then we need the x, and then we put in -9 for the value of the y-intercept. And that's it. Because there's nothing else to that. It's just put this here and that there, and we're done. So now graphing lines, all right, 74 and 39. All right, so now when I'm looking at graphing, I'm going to talk about that now. We're looking at identifying the parts of this in association to the y equals mx plus b, the slope-intercept form of a line. So we notice that it doesn't have a b, so we're going to go ahead and put 0 for that value because we don't see it. Now, graphing is very simple. We start by graphing the y-intercept, and being that it's a 0, we're going to be graphing a point right at the origin. Now, the slope is understood to be 2 over 1. Why do we care about that? It's because that's the rise over the run. All right, rise over run. So the rise is +2, and the run is +1. So that means we're going to go to the right 1 unit and go up 2 units. So then from there, then we're going to go 1, 2 over 1. We could do it from this up 2 over 1. We could put another one. And by keeping consistent with that line, that trend, we would get the graph of that. All right. So there's our graph. And it's that simple. So we're going to go ahead and graph that now. So I like to put a couple dots. So we put a dot here, up 2 over 1, put a dot there, and then connect those 2 points. And that's it. That's how fast this works. Now, the table of values of a linear function is shown here. Find the y-intercept. The y-intercept is whenever x equals 0. So the y-intercept is 6. Now, to find the slope, remember what I taught you before with finding the value of 2 points, the difference between 2 points, the slope formula. So what I'm going to do is I'm going to grab 2 points. It doesn't matter what the 2 points are. I'm going to grab 2 points. The first one, because that's what I tend to do, is look at the first one. And the second one. Doesn't have to be. I could have chosen the third one if I wanted. But I'm going to go ahead and find the slope now of these 2 points. Remember what I taught you before. Switch the signs of the second one. We don't switch the signs of it, 0. But then we add our y's together, add our x's together, all right? And then go ahead and simplify. And there we have our answer, all right? So we go ahead and put -3. And now the equation is following, just basically putting it into this, y equals mx plus b. So I'm going to go ahead and do that. So y equals, and then the m, the slope, is -3, x, and then the y-intercept is 6. So plus 6. All right, that's how simple this is. But depends on, if you're paying attention. Let's do another one, just in case you didn't catch that. So the first thing I'm going to do, I'm going to look for the y-intercept, which is when x equals 0. So I find that they give me that value. So x equals 0. The y-intercept is -1. The slope, we go ahead and extract out 2 points. So I'm choosing the first one and the second one. Like I said, it don't matter. Switch the signs of the second point. Add my y's together. Add my x's together. And then simplify. So now I have 3 for my slope. So my equation is going to be y equals, and then the slope of 3x minus 1. All right. So we approach that. Now for determining whether the slope is positive, negative, 0, or undefined, you read graphs from left to right. So reading this graph from left to right, it is going up as though we're going up a hill. So that's positive slope. When it's flat line, it's 0 slope. And from left to right, when it's going down, is negative slope. And then when it's vertical, it's undefined. So those are the 4 different ways you can have a line. A construction crew is lengthening a road. The road started with a length of 58 miles, and the crew is adding 2 miles to the road each day. Let L represent the total length of the road, and D represent the number of days the crew had worked. Write an equation relating L to D, then use the equation to find the length of the road after the crew has worked 39 days. So the length of the road, L, capital, notice how they're using those, is equal to 2 times the number of days is 2 miles per day, and it already started with the length of 58 miles. So we have 58. So now you can take your calculator, all right, take your calculator and do the 2 times the given value of 39, and then add to that 58, and you get 136. All right. Again, you guys aren't shy. If you want to ask me questions, just ask me anything you need. If there's something that gets you stuck. So Isabel is putting money into the savings account. She started with $450 in her savings account. Each week she's adding $40. So S represents the total amount of money in her savings account. So S is equal to the $40 per week, which is then W, and then plus $450. All right. So total amount of money saved at 13 weeks is taking 40 times 13, adding 450 to it. And so you get 970. All right, now we're looking at the construction length, construction crew length in the road again. All right, the crew is adding 1 mile to the road each day. All right, now the road originally measured 14 miles. So we're looking at the equation then of what we did before, is where L, the length of in miles of the road, is equal to 1 mile per day. So we're just going to put D is it's 1 mile each day, plus the 14 miles that we originally had. So now, looking at this, we're going to go ahead and go to 14, because we want to go 14, and it's adding one per day. All right, we can keep on going if we want, but then we're going to connect it. All right, and that's it. All right, pretty straightforward. So Sugar Sweet Company is going to transport its sugar to market. All right. So now it's the cost of renting the truck. All right, the total cost is equal to the $125 per ton of sugar, and it's plus the $32.50 for the renting of the truck. So now graphing that, we start at $32.50, so we're going to be, well, it looks like we need a coordinate point. So we need to plot a point anywhere. Okay. The coordinate point that we need is 0 and then $32.50. Whoops. We need the x to be 0, and then it's going to be $32.50. Plot that point, and that's what we needed. All right. I'm glad to be able to show you that, because you wouldn't have been able to do it just by freelancing it. Now, I need to go ahead and find another coordinate point based off of 1. So if I go ahead and go, okay, x is equal to 1, meaning that's the first time, I need to add 125 to $32.50. So that's going to give me 3,100. Excuse me, 375. And I need that plotted. And now I can join those 2 points right there. All right, so you need to understand that's what that button's for, is plotting points. Is there any questions on that one? That sticks a lot of students. All right, you guys are quiet, but I'm pretty sure that I was being articulate about that. But they're going to probably have another one like that, I hope, anyway. All right, now what is the temperature at 0 kilometers? We've had this kind of problem before. So at 0 kilometers, the temperature is 40 degrees Celsius. All right, choose a statement that best describes how the height and the temperature are related. As the height increases, the temperature decreases. That makes sense. At what rate is the temperature decreasing? Well, it's decreasing by 8 degrees Celsius per kilometer. You've done this before in other previous problems or previous sections. All right, what is Raphael's total pay with 0 hours of overtime? Is 100. All right, because it's right here. Then as the amount of overtime increases, the total pay increases, of course. All right, and that is by how much? It increases by $75. All right, got that one correct. A bucket is being filled with water. How much does the height of the water increase for each second the water is running? Well, for 1 second, it's increasing by 15 millimeters. And then what's the slope is the same exact value. It's 15 over 1. Now, graphing of this line, I'm going to go ahead and graph -8 first, and then go up 3, 1, 2, 3 over 1. And then I'm done. Start at -1. So start at -1. Go down to 1, 2 over 1. And then that's the slope we're looking for. So we're back to writing the equation. So it's y equals -5x plus 6. All right, so they're just giving us a couple more examples of writing equations. So again, if you have any questions, let me know. I'm just kind of punching it in there so we have the entire lesson complete. And of course, this, and this. All right, so we're done with this assignment. We got one more question and then we're done. All right, so the equation, so it's going to be the height of a plant, h, is equal to 1 centimeter per month plus the 55. And then I just go ahead and do 88 because 33 plus 55 is 88. All right, and that draws to conclusion of this particular lesson. Are there any questions about lesson 3.7 now? All right, well, in that case, I'm going to stop the recording.